Hello, in this video, we're gonna go over our quadratics unit. This is lesson 5, where I'm gonna go over how to tell if a table of values is linear or quadratic. Now with linear, our basic parent function would look like y equals mx plus b. And how you're going to tell that your table is linear is by seeing what we call our average rate of change happen every single time. And it'll be a consistent rate of change from element to element in the table. Quadratic functions, the parent function looks like this: ax squared plus bx plus c. And the difference in your tables, you're going to see, isn't going to be what's called your first difference, like linear. It's going to actually show up in what is called the second difference. And so I'll show you what that means here. So for the first picture here, look at our x values, how they go from -2, 1, 0, 1. So because these go in order, I'm going to track, is it the first difference that is the same, or the second difference that is the same? And I'll show you what that means. So first difference is linear, second difference is quadratic. So 5 to 7, that change is add 2. 7 to 9, that change is add 2. 9 to 11, that change is add 2. Notice how this difference that I tracked is all consistently the same. That means this represents a linear table. But then as I look at the next table, from 2 to change to 3, and again, look at how my x column goes up consecutively, 0, 1, 2, 3. So I'm going to just track the y column here. From 2 to 3, that change is up 1. From 3 to 6, that change is up 3. And from 6 to 11, that change goes up by 5. So this first difference is not the same, which means it cannot be linear. But watch the second difference. From 1 to 3, that change is up 2. And from 3 to 5, that change is up 2. And because the second level of tracking the change is the same, that is what makes this quadratic. And that is true for every table. It doesn't mean that the difference has to be the number 2. It just means that when you first track what is changing in the table, that number will be the same every time right away for a linear pattern. But whatever that difference is the second time, that is what you're going to see for quadratic. The second difference will always be the same. Okay, taking a look at the last table, I notice that as my x's are going up, my y's are this time going down. So I'm going to track this would be down 1. 8 to 5 would be down 3. And 5 to 0 would be down 5. Now these are not consistently the same, which means that this is not going to be linear, but watch the second difference. From -1 to 3, that's down 2. From -3 to 5, that's also down 2. And this difference is the same, which makes it a quadratic. And that is my mini lesson on tables.